let's talk about another developer fundamental. And this one is commenting your code. Up until now, you may have seen me add comments to our scripts. For example, right here, I added a comment of booleans. And this tells the Python interpreter, hey, this is a comment, don't run this, it's just for me, you can just ignore it and skip over to line 2. And you saw that I simply did that in Python with the pound sign. As soon as Python sees a pound sign, it adds a comment. And you can do that after a line as well. I can say, this assigns to a variable. And although this may look like 2 lines, it's actually just the word wrapping that's happening. And you can see that the interpreter just completely ignores these comments. Now, commenting sounds very, very simple, but it's an important concept. And if you want to be a good programmer, in all languages, we have commenting. But there's good ways and bad ways of commenting. And this is something that comes with practice. But here are some key guidelines. When you're commenting your code, the idea is that you're adding valuable comments. That is, if I add a comment here that says, hey, this is assign name variable a value of Andre string. A comment like this is not really good. Why is that? Well, because your code should be self-explanatory, right? The idea is for us to write code that is easy to read, easy to understand. It's not trying to be clever. Instead, it should read like English. And any Python programmer would know that here we're just simply adding Andre as a value of name. We're assigning a variable. And adding a comment like this that's self-explanatory just adds clutter to your code. So there's a trade-off here. It's good to comment your code for, let's say, if you're working on teams and other developers come and they want to understand your code. But you have to remember this principle of code being easy to read. The only time you want to add comments to your code is, well, when something really, really important is happening, where it might be a little complex. You first decide, hey, is this code written in a way that makes sense? For example, if this was variable A and this was variable B, well, this might be really hard for somebody to understand. So you might say that this is cool flag. But before you add that comment, you want to say to yourself, maybe my code is hard to read. Maybe I should just change the variable to is cool to make it more understandable. Now, this is something that you improve upon more and more. And you do want to use comments as an extra tool to make your code understandable. Maybe you write code that 6 months from now, you want to go back to understand what you did. But remember, more comments doesn't necessarily mean better code. You want to be concise and keeping things simple, while adding comments only when necessary to help others understand your code, not trying to make your unreadable code more readable. We'll explore this topic and give you advice on it throughout the course. But remember this key developer fundamental, because you're going to need it throughout your career. By the way, this article over here has some really important points that I think you'll really benefit from, especially in the commenting best practices. You can read some of the do's and don'ts and what some of the top programmers do when commenting. I know it sounds silly, but it is an important concept that most courses overlook. So I highly recommend you read over this. I'll link to it in the resources, and I'll see you in the next video. Welcome back. Let's talk about our next data type, and it's a big one, a very, very useful one. It's called list. And list is an ordered sequence of objects that can be of any type. So you can think of them as strings, right? We had strings previously that we learned about, except that each sequence of the string, well, was a string, was a letter or a number wrapped in quotation marks. Lists, on the other hand, looks something like this. Let's say we create a variable, li, and lists we denote with square brackets. And inside of these square brackets, we can have different objects. So for example, we can have 1, 2, 3, 4, 5. We can also have, let's say, li2, and this is going to have a B, C, and it can have any collection of items that we want. We can even mix and match and say that we have 1, 2, then A, then maybe even the Boolean value true. So all of these are lists. Now, lists are extremely important. And in other programming languages, you might have heard the word arrays. So in Python, lists are a form of array. And later on, when we get into the modules section of the course, we will talk about the difference between lists and arrays. But if you are coming from a different programming background, then lists are like arrays in your language, a collection of items. Now, the neat thing about lists is that it's the first data structure that we're learning. Now, what is a data structure? Data structure is a very important concept in programming languages. It's a way for us to organize information and data into, let's say, a folder or a cupboard or a box, so that these data structures can be used with different pros and cons. For example, you have a fridge where you store your food. And fridges are really, really good at putting your food inside, keeping it cold, and then taking it out. Or you might have a backpack. A backpack is really, really good to stuff everything in there, but when you're looking for things in a backpack, it's really, really hard. So you can think of data structures similar to that. A container around your data that has different pros and cons of accessing that data, removing that data, writing data. But that's something we'll get into a little bit later. The key here is that these square brackets allow us to contain information and data like strings, integers, floats if we want to, booleans, into a contained fashion. So let's think of a good example here. What if we had a shopping cart? Let's say we're Amazon here. And then Amazon has the Amazon shopping cart. And in here, we can collect different things that we want. Maybe we collect some, I don't know, notebooks. And you know what? Let's get some gadgets. Let's get some, maybe some sunglasses. We can add different items here, different strings, different data into this cart. And now, just like we saw in strings, we can access the Amazon cart in different ways. For example, I can access it, again, with square brackets, and simply say I want item 0. So if I print here and do Amazon cart, look at that, I get notebooks. The second item, I get sunglasses. What about the third item? Nope, list index out of range. But this should make sense now. This is a list where we're accessing the index of, but it only contains 2 items. So if we're going 0, 1, 2, the third item, nothing exists. So our program says, that doesn't work. You're doing something wrong. And just like strings, these list items are in memory, in their separate bookshelf, right? But one right next to each other. So we can go 0, 1, 2, 3, 4, 5, so on and so forth until the list ends. All right, let's learn about lists a lot more in the next video. Bye-bye. Welcome back. Let's continue with lists. Now, so far, these square brackets, we've seen them before, right? We saw them when working with strings. And just like strings, lists are quite similar in that we can use list slicing. If you remember, with string slicing, we had things like hello, and we were able to assign it to a string, let's say a variable string, and we could do string and then slice. So do something like this, where we have the start, the stop, and then the step through. So that we start at index of 0 and end at index of 2, and then go one by one. So list slicing is also available to us. So let's make this cart a little bit bigger. And you can actually just make things cleaner by formatting it this way. All right, so what should we add to our cart? We'll also add some toys. And then, you know what? Amazon does groceries now, so let's add some delicious grapes. Awesome. Now, let's say I wanted to get every single item in the cart. Well, we just simply do this, and we have our entire list. But let's use some list slicing. Let's say I wanted to grab from the first item to the second item. If I click Run, I get notebooks and sunglasses. Maybe I want to go all the way till the end, but skip every second one. I get notebooks and toys. We start at 0, we step over to toys, and we step over and we're done. Awesome. And this is something that we've already seen when talking with strings. Okay, but here is where it gets interesting. Remember how I said that strings are immutable? That means we can't change them, right? And we talked about this when we had a string like hello. I couldn't do greet 0 equals to, let's say, Z. I'd get an error here. I get str object does not support item assignment. It's immutable. But the interesting thing with lists is that they are mutable. So that if I change my Amazon cart and say that, you know what, I don't really want notebooks. So I'm going to grab the first item, which is notebooks. And instead of notebooks, what do we want? We'll say we want a new laptop. It's a big upgrade. When I print this Amazon cart, look at that. I'm able to change this list. And it didn't give me an error. In that sense, lists are mutable. We simply replace on the memory bookshelf of our computer notebooks, and I say, hey, change it to laptop. And they let us do that. Okay, so that's awesome. But let's try something here. What if I create another print here? And in the Amazon cart, I'll use list slicing. So let's say I want item from index of 1 all the way until index of 3. Let's run this and see what happens. Try and guess. Is that what you expected? Let's go through this code. When we get to line 10, we grab the Amazon cart, which has been updated with laptop, and I grab item 1 to 3. So that is sunglasses to toys. So 0, 1, 2, and then we stop at 3. Just to make this easier to understand, let's start off with 0 here, so that we see that laptop has been changed. And then here, in the second one, on line 11, we print the Amazon cart. But hold on a second. This list did not change. And that is because with list slicing, we're creating a new list, a new copy of this list. So here we're creating an entirely new list so that I could actually assign it to a variable. New cart is going to be Amazon cart. And let's just do the same thing here. And new cart is an entirely new list on its own. I could change new cart, let's say 0 into, let's say, gum. And if I print this, you see that I have 2 new separate lists. But a list is mutable because I can change whatever is at the index anytime I want. And every time we do list slicing, we create a new copy of that list. But I have a tricky question for you here. What happens if I just do this? If I run this? Did you see that? Instead of slicing my list, I simply said that new cart is going to equal the Amazon cart. And I changed the new cart, index of 0, to equal to gum. But now my Amazon cart got modified as well. Why is that? And this is a bit of a tricky question that you might encounter in an interview. The reason is that right now, the way that I did equals means that, hey, new cart is going to equal Amazon cart. And what does Amazon cart equal to? Well, Amazon cart points somewhere in memory in our machines that says, hey, this is what Amazon cart is. So because here we're not copying the list, instead we're just saying, hey, the value of new cart is whatever is in the memory of Amazon cart. We now, when we modify new cart, are simply changing the Amazon cart all the way back from here. So this is an important concept. If you want to, let's say, copy a list, then you do something like this, where you copy the entire list, and this is something that you'll see a lot in code bases. But this line is saying, hey, I want to create a copy, use list slicing to copy this Amazon cart, and it's going to equal new cart. So that now, if I run this, you'll see that the original Amazon cart stays the same, but the new cart is now something different. This is a quick gotcha that you just have to get used to, but it's an important concept. This idea of copying versus modifying the list. And it's something we'll explore a little bit more in the next couple of videos. For now, take a break, and I'll see you in the next one. Matrix is a way to describe 2D lists or multi-dimensional lists. What do I mean? Well, I can create a matrix, and this is a name that I just made, so I can call it whatever I want. But usually these are called matrix in programming. And it looks something like this. It's an array with another array inside of it. So let's say, for example, I have 1, 2, 3 here, and then another array, 1, or let's do 2, 4, 6, and then another array, 7, 8, 9. What's happening here? Well, it's a two-dimensional array. We have the main array, and then we have sub-arrays. 3 arrays to be exact. Now, why is this useful? And by the way, this is two-dimensional, but we can have multiple ones. For example, we can have another array inside of this array. But why is this important? These type of matrices come up a lot in topics like machine learning or image processing. For example, a computer doesn't really know what a photo of a dog is. The only thing it understands is zeros and ones. So a lot of photos, for example, let's say we had a very simple photograph of a giant X, maybe this letter X. Well, a computer can understand an image based on pixels on the screen. So maybe we can have 0, 1, 0, 1, 0, 0, or sorry, 1 here, 0 here, and then 1. And right now, a computer can look at this. And if this represented, let's say, a tiny little pixel here, or maybe a pixel here on my screen, the computer is going to say, oh, there's a 1 here, so that means I should make this green in this corner, then dark here, then green, then dark, green, dark, green, dark, green. And a computer is able to draw, let's say, an X. And this is a simple example. And using matrices, we can do a lot of these heavy calculations. And that's how computers work underneath the hood when, let's say, for example, it's trying to display something. But the reason I wanted to talk about this here is when you want to access a multi-dimensional list, well, you would do something like this. Let's say matrix access the first item in the matrix, which in this case will be this first array because it's the first item. And then let's say we want to access the 0 in here, or let's change this to 5. Well, I'll do square brackets again and just do 0, 1. So if I go 1 here, and let's print that out. And I click run, I get 5. So it's accessing the first item in the array. So it's going to look at the first outer array, grab the first item, which is right here, and then grab the second item in that array. So 0, 1, which is 5. And you can keep doing this. If you had multi-dimensional arrays, you can keep adding, keep adding, keep adding to access that information from an array or list. But remember, in Python, we want to use the term list. I'll see you in the next one. Bye-bye. All right, let's learn about some actions that we can take on lists. And this is very exciting because you can perform a lot of actions on lists. Now, we've learned about built-in functions, right? Functions that come with Python. And we've actually seen this one before when we talked about strings, which is the length function. And here we can have it calculate the length of a list. So for example, if we had a basket here that had 1, 2, 3, 4, 5. Well, this basket, if I calculate the length of the basket, let's do print here so we can see the result. And I click run, I get 5. The length of the basket is 5 because, well, there's 5 items. Remember, a length is the actual length. It doesn't start counting from 0. It's going to do human length, which is 5. But lists get really powerful when it comes to methods. So instead of a built-in function, remember, a method is an action that's owned by something. And it's specific, let's say, to a data type. So if we go to list methods, you'll see that Python has a few list methods that we can use. And the way we use these methods is, remember, we just add a dot after a list. So let's have a look at some of them. First, I'm going to start off with the adding ones. So let's say in this basket, we want to add something to it, to the end of the list. Well, we can use the append, and remember, with a method, as soon as you write the dot, it'll tell you what we can use, which is very, very useful when you have an editor. So the first one is append. And if I hover over this, well, it just tells me appends an object to end. And in Python, an object is, well, everything in Python is an object. A number is an object, a list is an object. So just think of it as an item for now. So if I want to append, let's say 100 to the end of the list, and you know what? Let's add a new list here. And this new list will do the append for us. If I print the new list and I click run, I get none. That's weird. What if I print basket here? If I click run, all right. So it looks like the basket was appended to. We added 100, but a new list, when we assigned it the basket.append, that new list is completely none. And that is because append changes the list in place. What does in place mean? It means that it doesn't produce a value. All it does is saying, hey, I'm just going to append 100 to this basket that you gave me. But I don't really care. I'm not producing a result. I'm just changing this for you. I know it's a little confusing. So in order for our new list to have that 100 at the end, we have to do something like this. If I click run, there we go. After we've appended to the basket, then we can assign, so that new list points to basket, which points to this list that was modified. All right, what else is there? Well, there's also something called insert. And you see over here that insert gives an index and an object. So we can insert something not at the end of the list. I mean, we could, but we can also insert it anywhere we want in an index. So for example, in this case, if I do insert 100 at 0, 1, 2, 3, 4, so let's do index of 4, and I click run, I've added 100 to the index of 4. If I do index of 5 and I click run, I've added 100 at the end of the list. Now let's try and copy this and see if we can just add it into here. If I click run, again, same thing. Insert modifies the list in place. It doesn't create a new copy of the list. All right, and if we add this like this, well, once again, insert modifies the list in place. That is, it doesn't really output a new list, it just modifies whatever is existing in memory. Finally, there is another method called extend. And extend, instead of an actual item or object, takes what we call an iterable, which we're going to get into later on. But it's something that you can loop over, you can iterate over, which is a list. So we just give it another list, like let's say 100 or 101. So if I run this, once again, it doesn't output a new list, it just modifies the list in place and adds on or extends our list. And we can also just give it one item. All right, let's keep going with the removing methods. Now, with the removing, we once again have a few fun things that we can do. So let's continue with this basket that we've been using that now has 100 included into it. And the way we can remove things is, well, there's a few ways. First one is basket.pop. And basket.pop, if I go like this, and let's print this basket, I'm going to comment out the new list for now, since we're not using it. And then we're going to say basket.pop, and then print basket. Let's run this. And pop pops off whatever is at the end of the list. In our case, at the end of the list, because we've extended the basket to 100, that 100 gets removed. If I do basket.pop again, not here, down here, and I run, you see that both 100 and 5 get removed. What if I do pop 0? If I click run here, it removes the item in the index. So here, pop 0 is going to remove whatever's at index of 0, which is 1. Now, there's also .remove. Remove, again, is we give it a value that we want to remove. So in our case, let's say we want to remove number 4. Well, if we run this, it's going to remove 4 for us. So remove, we give it the value that we want to remove. With pop, we give it the index that we want to remove. And just to see if this is working, let's add a new list here. And we'll say new list equals basket.remove. Add a new list here. See if that gets modified. Nope, it does not get modified. That means remove is working in place. It doesn't return a value. It just simply changes whatever list you give it. What if we do pop? If I run this, I get 5. Why is that? And this is something that you just have to get used to. Different methods do different things. For example, pop, the way it works is that pop returns whatever you have just removed. In our case, when we did 4, that is index of 0, 1, 2, 3, 4, it returned the number 5 for me. Even though it removed it from the basket, it still returned something. And the reason for others is that we got none. That is when a method doesn't return anything. It returns none, a topic we're going to cover shortly. So you have to be careful and understand what each method returns. If I go over extend, I see here that this little arrow shows me that none is returned. That means it's not going to produce anything with this method. It's only going to change or extend a list that it was given. Don't worry if this is confusing. That's something that you're going to get used to as we get more and more practice. Now, the last removing method I want to show you is clear. And clear, as you might guess, if I click run here, well, this is none. But if I go to basket and I click run, the basket is empty. Clear removes whatever's in the list, completely clears it, just as the name suggests. All right, that was a lot, but there's still a few more. So let's take a break and I'll see you in the next video. Welcome back. Let's keep going with some more string methods. Now we've learned about adding and removing ones. We learned about append, insert, and extend. And then in removing, we learned about pop, remove, and clear. There's a few other important ones. Let's go with the index. So instead of clearing here, let's clean this up. And we'll do basket dot index. And index, as you can see, we give it a value, a start, and a stop. What does that mean? Well, we want to say, hey, what index is number 2? If we do index of 2 and I click run, it's going to give me 1. I know this is a little confusing, but it's asking for the index. Where is number 2? Number 2 is at index of 1. Let's change these into letters just so it's more clear. So we have A, B, C, D, and then finally E. And again, if I do D here and I click run, I get an index of 3 because 0, 1, 2, 3. It's on shelf 3 in our memory. And you can also do a optional parameter here, which is where should we start looking? So I want you to start looking at index of 0 and then finish looking at index of 2. If I do run here, I get an error. It says, hey, D is not in list because, well, we started at index of 0 and stopped at index of 2. If I do 3 and I click run, no, it stops right before 3. So if I do 4 and I click run, there you go. I get 3. Now, errors are not good in our programs. Ideally, we don't want to get errors. So how can we avoid this? What if we're looking for something and we're not sure if it's in the list or not? There's another nifty way of looking for things in a list. And this involves what we call a Python keyword. A keyword is something that you use in Python that, well, already has some meaning. For example, a keyword here, if I go to Python keywords, are all these words that already mean something. Now, we're going to go through them, and we haven't seen a lot of them yet. But we might have seen true, right? In Boolean values, true means something. So in Python, we can't really use the word true because, well, it already means something. There's a word called in that, as you can see, as soon as we type, means something, is a keyword in Python. And this is quite nice. We can say, hey, is D in basket? And if I run this, I get true. Okay, is X in basket? I get false. Because, well, it doesn't exist. And this is actually quite useful, and we can even do it for strings. For example, if I'm looking for, let's say, the letter I in a word, and let's say it's I in hi, my name is Ian. If I click run, I get true because the letter I does exist in this string. All right, let's learn another one. Another one is basket.count. And we can count how many times an item occurs. So for example, if I do D and I click run, I get 1 because D only exists once in the list. But if I add another D in here and I click run, we get 2. It counts how many times this value occurs in our list. Very, very useful. All right, a few more still to go. Let's do some exercises and I'll see you in the next one. All right, it feels like it's never going to end. We have so many methods with lists, but like I said, lists have a lot of methods because you can do a lot with them. It seems like a lot right now, but trust me, these are going to become second nature. So hang in there. I have a few more to show you. The next one is called sort. Guess what sort is going to do? If I click run, I get none. But remember, sort sorts the list, as you can imagine, in place. That means it modifies the list. So if I remove this up to here and then do sort or do basket, and I click run, look at that. I get a sorted list where D was moved in front of E. If I add, let's say, X at the beginning here, and I click run, it's going to move the X all the way to the end. It's going to sort the list in place for me. Again, if I hover over, it sees that it's going to not return anything, which is why our print initially didn't work. We had to print our basket, not whatever this produces, which it doesn't produce anything. But what about this one? If we go to built-in functions, I have something called sorted. And if I do sorted, and because it's a function, not a method, I can do sorted dot or basket. So around the brackets, just like print. If I run this, all right, nothing has changed. But what if I remove this and put it in here? If I click run, I get A, B, C, D, D, E, X. What if I comment this out? So that we're not sorting it anymore. We just have the basket and then we run this sorted function. If I run, did you see that? Sorted, I know it's confusing. Why do they even have 2? But sorted produces a new array. So if I do print basket here and I click run, the basket hasn't been modified. The basket still remains the same. It's this one over here that's not sorted. Sorted, on the other hand, doesn't modify the basket in place. Instead, it creates a new copy of the basket and sorts it. It's almost as if we're doing this. We're saying new basket equals basket, and then we're going to copy that basket. Remember, list slicing. And then we're performing new basket dot sort on this new list. So that if I do new basket and I click run, we get the same thing. So you have to be careful of certain actions that perform an action in place or create a completely new list to begin with. By the way, there's also, instead of this, a dot copy method that we can use. And if I run this, again, we get the same thing. copy, just as the name suggests, copy the list for us and returns for us a new list. All right, one last one, and that is basket.reverse. What do you think this does based on the name? Well, if I check out the basket here and click run, is that what you expected? It reverses the basket in place. But notice that it's not like sort. It's not sorting. It's simply switching all the indexes into opposite sides. So D is now index of 0, E is now index of 1, index of 2, 3, so on and so forth. So you can see here that it doesn't actually sort it. Instead, what we might want to do is sort first, then reverse, and if we click run, we have a sorted, reversed basket. This is a little tricky one that some interviewers might ask. All right, good job getting this far. We're almost done with lists. So I'll see you in the next video. Bye-bye. Welcome back. Let's talk about some useful tricks with lists that you'll see a lot in Python code. Well, one we have already seen. It's this idea of length. You're going to be using this a lot. That is to figure out the length of a list, which in our case is now 7. Another really useful trick is to reverse a list. Now, I've already showed you how to reverse a list, but sometimes you can do that with list slicing. Again, something that we've seen in string slicing. So I can actually do basket and then semicolon, semicolon, -1. If I click run here, is that what you expected? Let's go through this line by line. I've sorted the basket so that it's from A all the way to Z. And then I've reversed this so it's in Z all the way to A. And then I've reversed the basket again so that instead of being in reverse, it's now in order. A, B, C, D, E, X. And this list slicing creates a new list, right? If I print basket here, you'll see that the basket is the reversed version, the last action that we've taken on it, versus list slicing that creates a new version. So this notation you'll see a lot with lists when you need to reverse a list, or maybe you need to make a copy of the list like this, or maybe you need a portion of the list. Another useful thing that you'll see a lot of is something called range. Let's comment this out for now. If I wanted to generate a list really quickly, let's say from 1 to 100, I can do something like this. I can say range and then start and then stop. So let's do 100. And if I print this and I run, I get a range 1 to 100. But if I wrap this in a list, which is going to create a new list for us, and I click run, look at that. I get a range from 1 all the way to 99. Remember, it's the start and then whatever to stop at. So before it hits 100, it's going to stop. Now, if I remove this and just do one single thing, I get a list starting from 0 all the way to 99. If I want a list that has 101 items because it starts at 0, I would just do 101. And range is something we'll talk about a lot more, especially when we talk about loops in programming. But this is a great way of you to generate a list really, really quickly, especially a numbered list. Finally, the last common thing that you'll see a lot is this idea of dot join. What is dot join? Join is actually something that works on strings. It's a string method, but it's often used this way. We have an empty string, and this empty string, let's say sentence. And then we can do sentence dot join. And join takes what we call an iterable, which is a list for now. And in here, we can have a sentence like, hi, my name is Jojo. And now if I print sentence and I click run here, I don't get anything. Let's figure out why. What if I type in an exclamation mark here and I click run? All right, it's printing out sentence, but it looks like .join creates a new item for us. So let's just assign that to new sentence. Now, if I do new sentence and print that out, we see that I get, hi, my name is Jojo. So this is a little funky, right? We have these exclamation marks between our items. And join joins these little iterable items, these lists, by whatever is in front of it. So if we actually change this to an empty string, click run, we now get this. If I add a space in between and click run, we get, hi, my name is Jojo. And sometimes you'll notice this pattern a lot, especially if you want to join and create a new string out of a list of items. Now, a shorthand way of doing this is to actually not even bother with this and just doing an empty string, dot join, and then joining all the list items. There we go. So all we're doing is combining lists into a string, and this is a common pattern that you'll see a lot of. I'll see you in the next one. Bye-bye. I want to teach you one last thing when it comes to lists, and it's called list unpacking. And it's a really, really nice feature. I really like it. With list unpacking, we can do something like this. Let's say I have a list that is, well, very simple, 1, 2, and 3. And I want to assign a variable to this list. Let's call it basket equals 1, 2, 3. But what if I wanted to assign a variable to each item? Well, I can actually do something like this, A, B, C. So that when I print A, and then let's print B, and then print C, and I click run, I get 1, 2, 3. And this is something that we've seen when we talked about variables, where even if it wasn't a list, as long as we gave it by comma, separated by comma, different values, we're able to print 1, 2, 3. But this is where list unpacking gets really, really useful. We can actually, let's say, extend our list to include all the way till 9. What if we wanted to unpack 1, 2, and 3, but keep everything else still in a list? Could we still do that? Well, with list unpacking, we can. All we need to do is say comma, and then add a star, and give it a variable name, whatever we like. Let's say other. So now if I print other, and I click run, look at that. I'm able to unpack my list however way I want. What if I add a comma here and add D? Well, if I run this, I get a list all the way until 8. But now D is, well, actually, the very last item. So that's very, very neat. Maybe the use case right now is not absolutely clear to you, but this is something that might help you, another tool in your toolbox, to unpack a list and change a list in different ways. We'll explore this more later on in this course. But for now, list unpacking. When you hear that word, now you know what it means. I'll see you in the next one. Bye-bye. Welcome back. when we talked about lists, we saw our special type of none, where some methods that worked on lists didn't really produce anything. They modified the lists in place, but the output of whatever they were doing was this thing none. Remember how we had in the output this none? What does that mean? If you remember, I mentioned none as a special data type that exists in Python. And most languages have something like this to represent the absence of value. In some other languages, you might have heard of null, which is another thing that, again, represents the absence of value. Now, why is this useful? Well, for now, it's hard to really conceptualize it. We'll see it being used a lot more as we get further into the course. But I could do something like A equals none. Let's say, for example, we're just starting a video game. And in this video game, we have a user's weapons. But when you're just starting the game, there are no weapons that the user has. Well, in that case, we might want to assign the variable weapons. Maybe in our code, we use this variable. But we also want to know that this user doesn't really have any weapons. It's none. So this is completely valid Python. If I run this, I get none. And we'll explore this a little bit more throughout the course, like I said. But hopefully this way, you're not intimidated when you see it. As the name suggests, it's just nothing. Let's talk about our next data structure. And this one is called a dictionary. In other languages, it might be called a hash table, maybe map or objects. In Python, we have this idea of dictionary, or as Python likes to call it, dict. I have to make sure I pronounce that properly. That's a really hard word to say when you're recording and you're repeating it over and over. Anyway, dictionary. What is it? Well, it's a data type in Python, but it's also a data structure. Remember that I mentioned this idea of data structure when we talked about lists. They were the first data structure in Python that we learned. It's a way for us to organize our data in a form that has some different pros and cons on how we access it. For example, with lists, we saw that they're easily ordered. We can access them through indexes like 0, 1. We can reverse them. We can insert into them. It was really, really nice. What about dictionaries? Well, let's see what a dictionary looks like. A dictionary will look something like this. We'll have a key and a value. And then another comma, and then another key, and another value. Let's decipher this. So I'm using curly brackets here, which denotes a dictionary. And unlike a list, we have what we call a key-value pair. A key is a string for us to grab the value. What do I mean? Well, in order for us to access any of these values, I would go dictionary and then say the key. In our case, let's say we want to grab B. We would grab the key, and then when we print here, the result, we get the value 2. We're essentially telling the computer, hey, I have this variable dictionary. Remember, I can name this whatever I want. I have this variable dictionary. I want you to go find the key B. And this key B, if it exists, grab me the value. So it's going to go into your memory or into the machine's memory. It's going to find where B is stored in our memory and grab the value. So in the bookshelf B, we have the value 2. What if we do C, which doesn't exist? If I click run, nope, I get an error. It tells me, hey, sorry, you're looking for key C, but I don't really have that key. And this is what a dictionary is. A dictionary is an unordered key-value pair. What do I mean by that? Unordered means that they are not right next to each other in memory. Remember, with lists, we could access lists with index of 0, then index of 1, index of 2. All those bookshelves were right next to each other. A dictionary, on the other hand, they're all over the place. Although I've put A and B here, this might be in one spot in memory and this one in another spot in memory. And if I added, let's say, X, this will be in another spot in memory. And this might not be in order. Maybe I've written it A, B, X, but when I actually return the entire dictionary, maybe I don't have this in order. These are all just scattered all across our memory. As you see here, when I receive the dictionary, I get these things in order, but that's only because it's small. If I had a really, really large dictionary, I might not have them in order that I've inserted it in. So a dictionary is an unordered key-value pair. And as long as we know the key, that is, whatever the key that we're looking for, then we just give that. And our computer is going to know, hey, where in memory to look to grab the values. Now, here's the cool thing about data structures, like dictionaries and lists. They're containers around data, right? So this can be anything that we want. Let's say we want this one to be a list, 1, 2, 3. Maybe we want this to be a string, hello. And maybe this is a Boolean value, like true. That is completely valid. I can access the A like so, and I get the list. What if I want the second item in the list? Well, I do index of 1, like this. And there you go, I get 2. And this is the same with lists. And you'll see this a lot, where if we had a list, or let's call it my list, and my list contains a dictionary that has, let's say, A, 1, and you know what? Let's just copy and paste this. We'll do this. So we'll have the first item in the array, like this, then comma, then another item in the array, and this time around, this one has 4, 5, 6. So that I can now grab from my list the first item in the array, and then maybe grab the A, that is the A key. So remember, this is a string. And then we want to grab, let's say, the third item. So we'll go 2. If I run this, I should get 3 and 2. There you go. Now, you might be asking yourself, what's the deal with these data structures? Like, why do we need dictionary? Why do we need list? Why can't we just have one thing that does everything? Isn't that simpler? Think about that, because in the next video, I'm going to try and answer that question for you.